So in the previous session, we saw that what is the power spectral density of NRZ, the unipolar format. And anyway, we can see the equation above, and this is the graph. All right, let's move ahead. So the next topic that we are going to see today is uh, the PSD of NRZ polar. Okay, now, so like always, this is some standard procedure. First, you define what is the AK value, right? For the NRZ polar format, I know I have to have polarities for both 0 and 1, correct? So let me define this. So AK could be, say, I'll assign a value plus A, say plus 2 volts or plus 4 volts, something like that. Okay, so that's the polarity. Whenever the symbol we are transmitting is 1, okay, and it's polar format, so you should have other polarity as well. So let's give a minus A, right? This is whenever the symbol that you are trying to transmit is 0, right? And you for a sufficient amount of time that is equal to the bit duration, you have to keep it either at plus A or minus A, corresponding to whether you are sending 0 or 1, right? So that's the concept, right? Whenever 0 completely for a bit duration equal to TB, you keep it as plus A or plus whatever volts it is, right? Similarly, whenever it is 0, you keep it at minus A. Fine, so we understood. Now I also have to define the required probability, right? Since there are only two symbols that we are trying to transmit, only two levels, plus A minus A, again equiprobable. All right, so I'll write probability that the AK becoming equal to plus A is equal to half. At the same time, the probability that the AK becoming equal to minus A is also half. So sum is once again 1. So we are good to go. Okay. Now, what is the next step? If you remember, we are supposed to calculate the RA, that is the autocorrelation, right? So let's write the equation for the autocorrelation, right? So autocorrelation equation is, I think we have written yesterday, but it has to be written for every answer whenever you try to write that. Okay, so to find the RA of n is nothing but summation. There is a variable I which goes till all the possible combinations. There are capital I number of combinations. Okay, so that's into, this is the possible AK into AK minus n, all the I possible multiplications like this, into the corresponding probability. This is my fundamental equation to calculate the RA of n. Okay, now let's see what happens. Okay, anyway, we always start with the n equal to 0. Okay, so when n equal to 0, it means AK into AK, correct? So AK into AK, in the sense I have only two possibilities, right? So that means I'm calculating RA of 0. So this is equal to, let's write the summation once again. This is I know that only two possibilities because there are two symbols. This has to be simply AK into AK, right? Two possibilities. So I into PI. Okay. So what are the two possibilities that you can consider now? One is simply A into A, isn't it? Right? So that means, can I write whenever I'm writing this? Okay. So this is A into half, correct? That's the first one. Other possibility is minus A into minus A, right? So plus, this is minus A into minus A, that's for 0, right? Again into the probability, that is half, right? So you can see that this is A square by 2 plus A square by 2. So that means it is simply A a square. That's right. So that's the case whenever it is equal to n equal to 0. Now I have other possibilities, like you can have n equal to 1, n equal to 2, n equal to 3, etc. You see that, right? In such cases, whenever n is not equal to 0, how many number of possibilities are there? I can have get both a's, right? All the possible combinations like we did earlier, like 0 1 1 0 1 1 and 0 0. Corresponding to that, in this case I have a minus a into a and minus a into minus a, isn't it? So 4 possibilities, equiprobable means 1 by 4. Correct? So let's write. That's my next case. That is when n is not equal to 0. This means I'm trying to calculate once again. It's autocorrelation, but I'll write RA of n, right? In this case, just now I calculated this. I takes value from 1 to 4. Okay, so this into the same thing. This is AK, but I need to write AK minus n now. I P. So let us write the terms one by one. So I'll start with the A, right? So this is A into its probability, that is equal to 1 by 4. Plus next one is A into minus A, its probability 1 by 4. Okay. Then I have next one, that is minus A into 1 by 4. And the last term, that is equal to minus A into minus A into 1 by 4. Right? What's the sum now? If you see that, this is first term is a square, second is minus a square, they will get cancelled. Third term is minus a square, last term is plus a square. So completely everything will cancel. You have 0. Okay, so that means, therefore, the required RA of n is equal to, the first term we got as a square whenever n becoming equal to 0. Right? At the same time, this is going to be 0 if n not equal to 0. So we got this. Right? So once again, it is either plus a or minus a, which means you are using v of t, right? What is the v of t? What's the equation for v of t now? Right? You see, I have the curve like this. So either I am going to send this, right? This is plus a, amplitude is plus a from 0 to tb. Okay, you know the equation. Yesterday we had it. Otherwise, if that's not what you are sending, you will be sending this, right? So it's simply minus a, correct? Amplitude is minus a, but still 0 to a. Not a, sorry, tb, my mistake. Just correct. 0 to tb. It's below the x-axis, so negative. Okay, fine. So this is the time axis. Now my question, I have one very simple question. If I had a signal that 0 to tb with the plus a as amplitude, if I take its a Fourier representation, I get a frequency plot. Okay, because the frequency plot talks about what are the frequency contents of that signal. That's all. Okay, it has, right? That's what I get. Now, if I have a signal which is minus a from 0 to tb, will the frequency content change? That's my question. Okay, you understood the question, right? I have the first signal, I take its Fourier representation, I get a graph. Because since the graph is always talking about what are the frequency content, so my question is, if I take the Fourier representation of the second signal, which is written below here, will the frequency content change? Some basic concept from signals and system, that's all. If x of t becomes minus of x of t, right? Because you can see that a becomes minus a, so x of t becomes minus. So it's the same signal, only amplitude is flipped. When the amplitude flipped, will the frequency content change? No, right? Right, so that means, right, no change in the frequency side, correct? So it's actually the same signal, right? I'm using the same function over here. So v of t, I can still write that as, right, what was our function? It is a rect function, correct? If you remember, this is a rect of t by tb. isn't it? So what is its Fourier representation? Do you remember? When you take its Fourier representation, correct. So whenever I take that, it's TB times sinc function of f into TB. All right, you remember that. That's very good. Okay, let's proceed. Now, what I can do, I can directly calculate the required power spectral density, isn't it? Because I got everything. I need a V of F and I needed RA of N, right? Both of them we have with us now. So directly let's go for the substitution in the equation, right? So we know that what we know the equation that is Sx of F. This is equal to 1 over the TB into magnitude of V of F the whole square into the summation n varying from minus infinity to plus infinity. This is R A of n into the e to the power minus j 2 pi f into n times tv. I hope you remember this equation. This is the standard equation of the power spectral density for a binary sequence whose uh, autocorrelation is RA of n and whose spectrum is V of f. Right. So I just have to substitute all the values back over here. Right. So this is 1 divided by TB into V of f. Anyway, we have that. Simply let's write it after squaring TB square sinc square f into TB. That's the square of this. What happens to the summation? What happens to this whole term? Right. Uh, can you answer? What should I write this as? Because you know the area of n. I'll just show you the area of n. Yeah, you can see here. Area of n is equal to a square when n equal to 0. It's 0 for n not equal to 0. 0. Look at the summation. Summation goes all the way from minus infinity to plus infinity, isn't it? Okay. So that means when n is equal to minus infinity, starting from minus infinity till minus 1, RA of n is 0, right? Similarly, starting from n equal to 1 till n equal to infinity, that's also area of n is 0. So the product area of n into e to the power whatever, that is 0. But when n equal to 0, I have an answer. So only that answer exists now. I don't have to write any summation. Simply multiply that by what number, what's the term I'm multiplying into. I'll simply write RA of 0 for your reference. Next step I'll substitute so that you will never forget this. Okay. Only at 0 it is valid. Other than that, everything is 0. Right. So that means I'll cancel one of the TB over here. So this is uh, this is TB into sinc square of f into TB, right? Into what is this area of 0? That is a square. So this gives us a result very quickly. So that is a square times TB into sinc square of f into TB. So this is the required Sx of f, which is the power spectral density of our NRZ polar format. Okay, so anyway, let's try to plot and see how this looks like. So there is a difference between this equation and the previous equation. Okay, let's later on we can compare. All right, so but I need to plot this. So if I write f into TB as my axis, and this is Sx of f, once again I can see that at it's a sinc function, so it will be at 1, 1 means it is 1 by TB, because whatever is the F, I multiplied by TB. Originally, this is 1 by TB. Since you multiply by TB to that, it becomes 1. Okay, so 1, 2, etc. Right, we have this. So it starts from 1, it comes down to 0, then comes down this and this. Okay, so this is 1, 2. So maximum amplitude is actually, we can write normalized one. You can see in the textbook, they write just 1 here, but don't get confused. We don't have to go for a normalization, because my equation says that there is this value like a square TV, right? Sync function gets multiplied by that. So that's why you can write it as a square TV, right? So don't get confused if you see something like 1 in the textbook. No issues, right? They are normalizing. In a sense, every value is getting divided by a square TV, so that you get the whole function becoming maximum value becoming equal to 1. Is it okay? All right. Now, let's move further. So my next intention is to find the power spectral density of the NRZ bipolar form. Okay, if you remember, the term bipolar suggests that I need to use, right, plus A and minus A for alternative ones, correct? Whenever I have two ones, it has to be represented by plus A and minus A, or plus 1 minus 1. But 0 will be a 0. Are you okay? Yes. So now let me write, therefore, the AK, right? So for a NRZ bipolar format, AK will be equal to, right? It's going to be plus or minus A, right? For the symbol, not 0, sorry, my mistake. For symbol 1, isn't it? Similarly, this is going to be 0 for the symbol 0. I hope this is fine. Okay, now you tell me the how do I write the probabilities, because I need this thing, because I need probability that AK becoming equal to 0. How much? I need to write that probability that the AK becoming equal to plus A, because I have a different symbol for 1. Two consecutive ones will be different. That's why I need to write this also, AK equal to minus A. Can you try to answer this? So in my message signal, right? See, the plus A minus A comes into picture only in the waveform coding technique, right? Whenever I have two ones, I just put it into plus A and minus A. But the waveform generator, wherever the message is created, you can still assume equiprobable, right? Message symbol. Sorry. Yeah. Can you repeat? Absolutely, that's perfect, right? Because zeros and ones are equiprobable. So 0 should get a probability of half, isn't it? Then it comes to 1. So the probability of generation of 1 is half, but that 1 will have two possible. Again, I'm assuming equiprobable case here. So you get consecutive ones equally probable. So it has to be 1 by 4 and 1 by 4. That's it. Perfect answer. All right, so we got this, right? So what's your next step? I am supposed to calculate the RA of N using the same equation we used earlier. So this is I to capital I, right? I need to write a not probability, sorry. This is A, correct. Okay, this is AK into AK minus N, all the possible I number of products into their corresponding probabilities of getting those products. I just have to multiply. right? Okay, so let us start with the first case. Like always, start with n equal to 0. Okay, when n equal to 0, just look at the possibilities now, right? What are the total possibilities? Let me write r. This means I am calculating ra of 0, correct? So let's write the summation later because I am not able to understand how many terms will be there. Let's write the terms below, then I'll put the summation. Okay. So simply I need to start from I. I just have to write just like this. That is AK into AK into I into PI. So if you are able to directly guess the answer, yeah, please go ahead. Otherwise, we'll write the possible terms, then we'll come back and fill this value of I over here. What do you suggest? Can't guess, obviously. Even I can guess. So let's look at that. So I know that AK into AK means what? The same term should come. Either it is something like 0 into 0 into the probability, which is half. Correct? Then you write plus. Other possibility will be plus A into plus A into 1 by 4. Are you okay? What is the other possibility? Minus A into minus A into 1 by 4, isn't it? So how many terms you have? Only 3, right? 3 possibilities. I understood. Right. So all the terms we wrote. That means this, the first term is how much? A square by 4. First term is 0. Second term is a square by 4. Next one is also a square by 4. So this has to be a square by 2. Isn't it? Are you okay? All right. Let's proceed. That is n equal to 0. Now I need to actually, in this case, you see there are 3 levels. When I say I'll say I'll go to the next one. This is only when we have more levels. I need to put n equal to 1, n equal to 2, n equal to 3, and so on. Okay, that's what. Since we never had this kind of cases earlier, so now there may be a question: why not? Why don't you club n equal to 1, 2, 3, and all others as a single case? Why don't you do that? That is just because here I don't have two values, two levels. I have three levels. Correct? So you can see I have something like a, 0, and a minus a. Right. Now you see the when I write n equal to 1, let me write an equation first, right? Then I'll make it clear. Okay. So n equal to 1 means it is RA of 1 is what I am calculating. So that is equal to summation I. I don't know how many terms. Let's write that later. You see, you are writing AK into AK minus 1, right? I into pi. What do you mean by ak minus 1? It means you are trying to take a ak and its next symbol, not the same symbol. Are you okay? Right? Like if I ak is a, ak minus 1 can be 0 or it can be something else. Right? 0 or minus a. Like that I have to write. That's the difference here. Right? So that difference would have been covered for any value of n in our all previous cases. Previous two cases, like since one number is 1, next number can be 0, next number can be 1. Correct? That's what we used to cover. And the next number could be same also. Correct? So 0, 0, 0, 1, 1, 0, 1, 1. We had 4 cases over there. Right? Yeah. We'll come to that. Okay? Right? Okay. So now you are getting the point. Now, since it's not possible to guess that value directly, I'll directly calculate. I'll try to substitute. Is it okay? All right. So let us try to substitute. This is equal to. So let us start with the both values being 0. So 0, 0 into 0 into, right? So what I have a 0 with the probability equal to how much? So actually, you can see now, this is something like I can have, see, I'll try to write a small note here just for your reference. Okay, so let me say I have, see, I have to take two combinations, correct? in the sense 0 0 0 1. Let me write. So first possibility is 0 0. Next is 0 1. 1 means you can have, you can always, when my first one comes, it is always A, right? Next one I'll write, I have a 1 now. This can be plus A or minus A, doesn't matter, right? Because this one could be the first one or the second one. I don't know, right? Anything. Next number should be 0, correct? This is my next combination. So I have another combination coming up where 1 and 1, they are together, correct? 1 1 means the second one is a continuous one, right? It has to be the immediate next one. So you see, if I write the first one as, sorry, if I write the first one as plus A, this has to be a minus A. But there is another possibility. What if you have three ones altogether, right? So I'll write the first one as 1, next one is minus 1, then you see next one is plus 1. So this is also possible, right? In this way, right? I can actually have, so you see this is plus A means it is minus A. I will club that with the minus A means the next one has to be plus A. Are you okay? Fine. Now you have the answer directly, right? So first let's write. So how many combinations do you have? You have only 4 combinations. Is it okay? Right. That was my note anyway. Right. So let me write that. So since 4 combinations, 1 by 4. So 0 into 0 into 1 by 4. First number. Next, plus. Second one, 0 into A into 1 by 4. Okay. The third one is plus. This is plus or minus A. Doesn't matter because you are multiplying by 0. Right. Into 1 by 4. Now you tell me what should I write for the last one, because this is plus. This is plus or minus A into minus or plus A into 1 by 4. Is it okay? What's the answer now? After you add, what you get? Yes, that's correct. What's the last term? Whenever the first is plus A, second one is minus A. So the product is minus A square. At the same time, if the first one is negative, second is positive, then also you get minus A square, correct? So your answer is always, irrespective of what is the case, minus A square by 4. That is n equal to 1. Okay, fine. Let us proceed further, right? Now, you have to consider n equal to 2, let's say. N equal to 2 in the sense, if I have 1, 0, 1, something like this, right? I am considering this and this, right? This is k, this is k minus 1, this is k minus 2. Okay, right? Similarly, what is the difference? If something is here like k minus 3, this and this is equivalent to this and this, right? So it doesn't matter whether it only when they are something like neighbors, k and k minus 1, you had to take care of all this. Now k and k minus 2 looks very similar for me because k and k minus 3 also very similar. There is no relationship, right? So can you club k greater than 1? Sorry, n greater than 1 to the same class like we did earlier? Is it, if you're okay with that, right? Can we club? So n equal to 2 is a separate class, that's for sure. But can I club 3, 4, 5 also to the same keys? That's my question. So n, can I write all the other values as n greater than? Okay, so in this case, let me write RE of n is equal to the summation I don't know how many terms I have. Let's see that later. So once again, it looks pretty much similar to us like we did earlier. AK minus n I to PR. Okay, now, right, you just have to think of what are the possible answers I'm going to get. Because of the answers, I may decide how many terms I have, right? See, it's like, what are the possibilities you have? You just have to think. Like, if I have one of the term, right? So let me consider. So k is 0. k minus 2, k minus 3 can also be 0. Are you okay? That's the first case, right? Then if I have a 0 here at kth position, if at all the k minus 1 is 0 and k minus 2 is 1, I can write a 1 here, like that is the a plus a, because it cannot be minus a because that's the first one. At the same time, I can have 0 here and I can get a minus a here, right? Is it possible? Because if at I'll write that case. This is 0. I got a 1 here, right? Once again, I get a 1 means this has to be minus a, isn't it? So this is 0, this is minus a. That's what is this case, right? So previous case 0a will be 0, 0, then 1 coming. Okay, right? All right. Then tell me what is going to happen. What are the other case? Is it possible to get two A's here, A and A? Is it possible? What if the what if this case? You see, this is K. So this is A, this is 0, this is A. Yes, A possible. Minus A possible? Minus A, minus A. No, right? So minus A not possible. A minus A possible? A minus A possible? A minus A, in the sense this has to be A, and I'm saying that irrespective of what is here I should get a minus A. Is it possible? Provided you get a 1 once again, correct? So if at all you get a one more 1 here, then this cannot be like this, right? This has to be like this. So A already covered, right? So just think about that and let me know the answer. Is it possible? And are there any other combination that can come here is my question. Okay. So what I should write next? Will there be any other combination or that's all? So this is a minus A. I already have written. Okay. So minus A and A. Okay, let's check that. Is it possible? Minus A and A. So if at all I have a value like 1101, you see that this is 1, this is minus 1, this is 0, and this is 1, right? So you see this is minus A and plus A can come, right? Take this as your first number, minus, because we are not worried about what is previous to. Somehow if I get a minus A, is there a chance of getting A in the, this is 0th position, first, second position, K minus 2. Will it be there? Yes. So that's right. Your answer is right. So we have minus A possible. Minus A and E are possible. Okay. So how many combinations you can see? Other than this, I think, let me check once again. We have any other possibility? Minus A is over. A comes first, 0 comes later, doesn't matter. It's already covered. I think only this much. Right? Okay. So I'll write 5 terms possible here. So whenever there is a 0 coming into picture, right, it has a probability that is equal to, right, 1 by 4. But whenever you have two A's in place, the probability will be 1 by 8 for that product, correct? So this is equal to first one, 0 into 0 into 1 by 4. Next one plus 0 into a into 1 by 4 plus next one 0 into minus a into 1 by 4. Anyway, it cancels all zeros. Next, this is important. So a into a into 1 by 8, then minus or sorry, plus this is minus a into 1 by 8. Correct? So a has a probability of how much? 1 by 4, right? It's because of that reason. All right. Ultimately, everything cancels. So you can see that this is equal to 0. This, right? Everything cancels out. Right. So that's 0. So now I'll write a clubbed answer for RA of n for this case. So RA of n is equal to, what was the first case? If you remember, when n equal to 0, we got a square by 2. This is when n equal to 0. Then the second case, we got minus of a square by 4. This is when n is equal to 1. And all other cases, I can write n greater than 1. Right. But actually what happens, there is a slight twist here. That is using the property of the autocorrelation function. Right? So do you have a rough idea what is the autocorrelation? What autocorrelation does? For example, if I do a autocorrelation of a function, I get an answer. I get another signal, right? What is that? What does that indicate? What is the meaning of that autocorrelation result? That's my question. If you know any, if you have a idea about that, please give me the answer. Or how do you calculate autocorrelation? Do you have you? I think you have used that equation somewhere, maybe in digital signal processing, or it might be even in signals and systems. Somewhere you have performed the uh, auto. Huh, perfect, right? So autocorrelation is calculated by by actually keeping two copies of the signal, some signal. One you fix it, second one you move from maybe minus infinity to plus infinity. Wherever you have overlap, you get an answer. Wherever you don't have an overlap, you don't have an answer, right? Perfect. Right. So this is to find out, as you told, it is used to find out the similarities between two signals, right? If you are trying to do the correlation between the signal and its own copy, or its own copy with the delay, it is called as autocorrelation. If you don't have the same signal or its copy, you have two completely different signals, you perform the correlation. It is called as a cross correlation, right? Since this is autocorrelation, it means I am doing the correlation of a signal with itself or its copy. So that's why this is RA of n. Okay, fine. Now there is a property of autocorrelation. Since you already have used autocorrelation somewhere, I think you will remember the property of autocorrelation is there is a property called symmetry. Symmetry of the autocorrelation function. It means if you have the RA of n, that is always equal to RA of minus n, right? Because n is the shift which you are going to give, right? So the shift can be positive or negative, correct? So because of that, now I'll slightly modify. That means my RA of n will be, it's a square by 2 for n equal to 0. No problem, because n equal to 0 or minus of 0 doesn't matter. But for the second point, you see there is a change. This is a square by 4 whenever n is equal to plus 1 as well as minus 1. Correct? Because this should hold good, right? RA of 1 should be equal to RA of minus 1. Are you okay? Right. So that's because of that I'm writing. Other than that, no change. Okay. So n greater than so not 0. This is 1. Okay. That's the property I'm applying, which comes from the symmetric properties of autocorrelation function. All right. I got RA of n once again. In this case also, you see right? Will there be any change in the V of t? Is it the same pulse which it's the same pulse, right? Either you have this or zero. Zero means zero, no problem. Otherwise, you will have a minus here. So it doesn't matter, right? It's a still same, right? So V of t is equal to, once again, we'll write the same thing, right? That is equal to rect of t by tb. So that means it's going to show you a Fourier representation that is given by V of f. So this V of f is nothing but tb into sinc function of f into tb. All right, so everything we got, let's substitute in the main equation of the power spectral density. So therefore, the PSD denoted by Sx of f. So the original equation, let's write once again. This is 1 by Tb into magnitude V of f the whole square into the summation where the n varies from minus infinity to plus infinity. I have to multiply the Ra of n with an exponential signal e to the minus j 2 pi f n times tb. So the same Fourier equation. You multiply by a complex exponential to convert the signal into the Fourier. But since you are multiplying by already taken Fourier, this becomes the power spectrum. Okay, right, let's substitute. So this is equal to, so let me write the term. I'll just look at my area of n because that's the main controller over here. I have RA of n for n equal to minus 1. I have the area of n for 0, n equal to 0 and plus 1. Only 3 terms, correct? I don't have all the terms from minus infinity to infinity. So that's why I can write this as, I can actually expand this summation in the next step before I substitute, right? So that is equal to, so 1 over TB, right? I can write the VF whole square as that is TB square into sinc square of f into TB. This is what is there. Then I'll write the summation. Instead of the summation, I'll expand and write. What's the first term? When minus infinity, when I come from all the way from minus infinity to plus infinity, the first valid term comes when n equal to minus 1, isn't it? So this is area of minus 1. And when n equal to minus 1, e to the power minus j 2 pi f, right, into minus 1 into TB, right? Because n is minus 1, I have to substitute. That's the first term. Plus, what's the next term? That is RA of 0 into e to the power j into 0. That e to the power 0 is 1. So I just write 1 over there. And the last term, let's write. So plus RA of plus 1 into e to the power minus j 2 pi f into plus 1 into TB. Hope you are fine with this. Okay, now let us put the let's put their values in place so that later on we can try to simplify. So the TB and a TB cancel. So this is equal to TB into sinc square f TB. What is RA of minus 1? RA of minus 1 and RA of plus 1 are same, and its value is minus a square by 4, right, into e to the power, this is minus of minus, the power becomes plus, e to the power j 2 pi f into TB. That's the first term. Plus area of 0, we can see the area of n equation, which is a square by 2, right? And the last term, that is plus area of 1 is once again minus a square divided by 4 into What is this? This is e to the power minus of j 2 pi f. The n has gone because we substituted 1 into tb. Is it okay? Okay. Now let us try to make a substitution. Okay, let me try to write it in this way. This is tb into sinc square of f times tb. Now I can see that in whatever is inside bracket, this is common, right? So I'll try to club the two terms with the minus a square by 4. So this is minus a square by 4 into the first term is e to the power j 2 pi f tb plus the last term, that is e to the power minus j 2 pi f into tb. Okay, so after taking that minus a square by 4 as common, okay, we took it out, and the remaining term there is a square by 2, isn't it? Okay, now you can see that we can apply one trigonometric identity. So that identity is, I'll write it here. So if you have e to the power j theta plus e to the power minus j theta, I can directly write that as 2 times cos theta. Do you remember? Something like this, right? So I'll just highlight this. This is the property which I'm going to use. Where I'm going to use, I'm going to use here. I can see e to the power j theta plus e to the power minus j into theta. What is the theta value? 2 pi f into tb. Correct? So I can replace that as 2 times cos something. So let's write that. So that's my next step. So this is still equal to the tb into sinc square f into tb. There is a minus of a square divided by 4 into, I need to write 2 cos theta. Theta is how much? 2 pi f tb. So plus a square by 2. You can see this 2 cancel. This is. So now once again I can observe that this a square by 2, this a square by 2 common. So whenever I have common thing, I will try to take it out. All right, so this is equal to a square tb by 2. So the a square by 2, I'll take it out, okay, into the sinc square of f into tb, right? I'll write a positive term first. So a square by 2 has gone out, minus cos 2 pi f tb. Okay, yeah. Yeah, this is the one we get. Okay, how do we simplify this? Anything flashes for this? What's the substitution? If you have 1 minus cos 2 theta, yeah, that's a half angle formula, if you remember, right? Perfect. So if I have 1 minus cos 2 theta, I can replace it as 2 times sine square of half of this angle. So 2 theta becomes theta. Okay, so normally it's actually called as a half angle formula. 1 minus cos theta equal to 2 sine square theta by 2. It's one and same. You can remember anyway, right? So this is the one which I'm using now. So 2 theta is there, where theta is simply pi f into tb. Okay, so that means let's try to write this. This is equal to a square tb divided by 2 sinc square ftb into, this is 2 times sine square of only the half of the angle. So 2 theta is there. Theta is pi f TB. 2 to get cancelled. So my final answer, Sx of f, the power spectral density is a square TB into, this is a sinc square of f into TB into sine square pi f T. So this is the final answer. All right. Now, how it should look like. Anyway, a square TB into sinc square, we already know that, right? To that, I need to multiply by a, not a sine function, but sine square function. Okay, so sine square is no negative terms, all positive, because if you remember the sine term, sine will be something like this, correct? This is sine wave. What is a sine square? It's positive, it's positive, that's a sine square, isn't it? Because I'm squaring, so this is positive, becomes, it's square, so positive only, bigger number. This is negative, negative into negative is also positive only, right? Okay, so I am multiplying by this kind of waveform to the previously existing waveform. If you remember, that is something like it starts from here, comes to 0, like this, right? Are you okay? Now, what is the final answer? So, therefore, this is a simple sine wave, okay? This is sine square, right? This is the other term, that is what is called as a square TB into sinc function, okay? That's a third. Now, actually, I need to multiply this into this because I can see that waveform in this equation, correct? Sinc square into that. So this is a sinc square, okay? Not just sinc square. All right. Okay, now I just have to multiply these two. All right. So can you suggest what should happen? What should be the graph look like? From where it starts? Because the previous waveform which we wrote was starting from 1. So now what should happen is my question. Same amplitude. You try to multiply point by point. Where the sine starts, sine square starts at 0. Correct? See, this point is 0. 0 into whatever is 0. So my waveform should start from 0, right? Okay, let you see, this is close to 1 and this is slowly increasing. So 1 into smaller number is a smaller number, correct? So my waveform actually slowly increases, okay? By the time this sine wave reaches 1, right? This is reaching 1 where? This is reaching 1 somewhere here, correct? When it is 1, it is already lesser than that, correct? You can see coming closer to a smaller value, which means if at all this is 1, it will not reach 1. It will be reaching somewhere here only, correct? Point by point multiplication. You see, this was 1 by TB, or if you are saying that this is F into TB, this is also F into TB. At 1, and this also 1, so it has to reach 0 once again, isn't it? So at 1, this is FTB we are plotting, it will come back, right? Then once again it repeats, but since my second multiplier is a smaller, it's going to be a smaller amplitude, and it repeats. So now you see that is a difference. That's how I trace out what should be the waveform of this, right? So it will repeat. So only the first shape, previous waveform was starting something like this and coming down. Now you see this is the difference between that. It is not starting from 1. So now my question is, this particular waveform which we have plotted now has more power or less power compared to the previous two cases? Less power, because right, the waveform shows lesser, right? So this actually takes lesser power. So again, as I told, you can make a comparison, or while making a selection, which one to be used, right? You can definitely use the Sx of f for that purpose. So now we have seen three different cases. Which is the one that has highest power? Can you think and answer? The first one or second, or this is the third, right? So first one, because yes, yes. Can you try to answer that question? Why? Yeah, it was starting from one, it is coming to zero, then I also increase. That's correct. That's one part. But in addition to that, let me show you the previous answer. That was also very similar to that only, but it is having slightly lesser power. This one. You see here, this is the second case, whatever graph you are seeing now. This has lesser power than the previous one. I'll show you the first case, right? Now you see here. Okay. Your answer is right. You told this is highest power. What is the difference? Because of which you said that this is highest power. Only one difference between this graph and the this graph. Same amplitude, same amplitude. Okay. There is a difference. You can see at zero, you have a delta function, correct? So zero frequency means what? What do you mean by frequency is zero? Means DC, correct? DC component. So this particular waveform has a DC component, right? But if I have a DC signal, I cannot transmit anything over there, right? It is simply wasting power. Only when you have oscillation, you can put something over there, like you do a modulation, you can send, correct? So now you see it is actually waste of power in this case, right? So there is a lot of power in this, but majority of the power, that is power at zero, is lost. You simply waste it. At the same time, the second case, you can see, right? No DC component, right? Power is there. It has more power, right? Closer to zero, also you have power, but it's not that's not a DC component. All right. So that's the one. Next one, since it is at closer to zero, right? Frequency equal to zero, I don't have any power. But as the frequency increases, I have some power coming into picture. Then only power comes down and so on. So this is also suitable if you are using a low power transmission. Okay. So we can make the comparisons in this way between the three different techniques we studied so far.